I was looking at, I really enjoyed Professor Chen's presentation, but I was amused that we actually put 1 million drones in the air for the price of one copy of that textbook. $500. We put $500 into the community, and just based on cash flow alone, we put 1 million drones in the air, including most of the drones you had in your own thing. So probably says more about the academic economics market than it does about drones. Well, so after this morning presentations of like amazing whats of like Skydio and Professor Tomlin's presentation and the and Zipline, it's a very hard act to follow in terms of whats. So I'm not going to tell you about the whats, although we do amazing things involving many of the stuff you saw right now in 3DRs, mostly in data and construction and geospatial and mining and all that sort of stuff. But instead, I'm going to tell you about the how. How does this happen? How did I go from a hobby with $500 of investment to millions and millions of drones in the air? And more to the point, how did this community go from a world that was largely academic, PhD scientists, aerospace companies, to one where startup companies like Skydio or Chinese startups like TGI can essentially dominate the future of aerospace? And the answer is that they didn't do it alone. I think there was a line that, Brad, you used the line that, if you want to go fast, go alone. If you want to go far, go together. And this is really what it means to go together. When we got started, I actually have no background in aerospace, although I have a physics degree from Cal. So, there was something there. I actually didn't know anything about flying things. Well, I do have 5 children who are very hard to impress. And I thought, robots will impress them. That was not true. Robots did not impress them. They've seen Terminator, Transformers, et cetera. It's really hard to compete with Hollywood. So I thought flying robots will impress them. And they had not heard the phrase flying robots before, so they were willing to at least try. And so we eventually put Arduinos and things like that in the air, and we created 1 million drones. And that still did not impress them. However, it impressed the hell out of me. That basically a guy in a community with a website could put 1 million drones in the air, now 4 million drones. And so the models, I was like, okay, what did we just do here? What have we created? I mean, other than a cool hobby and a fantastic community, what have we done? And I was like, well, we've created a platform. And of course, the analogy of an open platform that's successful is Android. And so so the model was, this is the model, the notion that drones are a computing platform, the notion that it's a full system, it's connected. It's like Internet of Things, it's edge computing, it's connected to the network, it's sensors in the sky. It's starting to look a lot like a smartphone. As a matter of fact, the only reason we were able to do it is because the guts of a smartphone, the MEM sensors, the GPS, the wireless, the batteries, all that stuff was essentially so cheap and moving so quickly thanks to the scale economics of Apple and Google and others that we basically just repurposed them as drone parts. And so we were able to do things that would have been unobtainium. 10 years earlier, we were able to do it. Our first autopilot cost $19. And if any of you know what AUVSI is, the Industry Association, when I gave a keynote at AUVSI in 2007, and it's a bunch of generals, and Lockheed Martin and Boeing, and they're all the generals there, and it's like Global Hawk this and Predator there. And I walked up and I said, I held up a $19 autopilot and said, this is the future of aerospace. And they didn't know whether to laugh or to lock me up for mental illness. They were sure I was wrong, and they were right. It cost $29 by the time we actually released it. So my bad. Anyway, so this was the model, the Android model, and let's see how far it goes. So this is the way we started, and so this is kind of the family tree, and it goes back in time. So back in the day, there were like I think I can walk around. That's cool. There are like robot people. That's mostly people here at the university. And then there were like RC people who are hobbyists. And I think as Adam mentioned earlier, that it was largely the intersection of these two. If you take like RC stuff, like electric motors, brushless electric motors, and lithium polymer batteries, and digital electronics, et cetera, that all got really kind of that started to be pretty easy to use. It wasn't like the bad old days where you had to like start a gas engine to fly a plane, et cetera. So that was good. And then the robot folks, like most of us, had also miniaturized our IMUs and our compute platforms and our sensors, and we were looking for ways to get them out from the physical world. And it turns out if you just put a robot person and an RC person together, you kind of get a drone. And that's what happened. I created this community, DIY Drones, largely to put these two together. I knew nothing about that. I knew a lot about this, and those people, the RC people didn't know anything about robotics, and the robotics people didn't know anything about RC, and yet you needed an interdisciplinary collaboration to make it work, and so we did that for a while. Then over time, but for us, make it work was post the code, including design files for the printed circuit boards and a bill of materials and things to solder, and then we're done, right? And if in fact you know how to fab a PCB and to solder fine pitch components, that's great. If you don't, you're like, I'm sorry, can you just make one for me? So we're like, okay, all right, we're gonna have to start a community to make stuff for people to make it easier for them. And it started with boards, and then it was boards and boxes, and then it was boards and boxes that were already soldered. That was a big leap forward. Then we took compilers out of it, and eventually we ended up making drones, and that was great. That was really important. And then the community sort of fragmented. The RC people really were not interested in autonomy. They were like the opposite of what Adam was talking about. These are people who like sticks. You remember in Adam's original video, there's a guy doing amazing acrobatics. Those are people who like flying things. I am not one of them. And those people who like flying things wanted to keep flying things. And so they fly for fun, they do things like drone racing, they fly for video, etc. And at that point, that's the manual flight world. And at that point, we're like, bless you, we want nothing to do with you. We think sticks are the enemy. We think, because I've put millions of drones in the air, I can tell you that people suck at flying drones. We were looking at it, because we get, every time one of ours crashed, it always reports back home why it crashed. 99.999% pilot error. Regardless of what they say, it's always pilot error because we can see all the stick movements. And basically our lesson from this is do not let people touch sticks. Now, there are people good at it, but apparently not most people. So then there's the autonomy side. And again, as Adam said earlier, there's lots of definitions of autonomy, but as far as we're concerned, autonomy is you touch a button on the screen like an iPad and everything else happens. No sticks. Do not touch the sticks. I was actually pleased to see the new Mavic 2 controller has no sticks, which is great. Sticks are the worst. So there's the two sides of that. One's the software side, and one's the hardware side. So originally we did both of them, and DJI does both of them. And that's the classic, vertical integrated stack. Then, as things evolved, some of those folks who like flying things actually could make businesses out of it. And as things like the FAA's Part 107, et cetera, allowed commercial use, some of them were able to become the kind of operators we were just hearing about, who could actually do flying for a fee, and that's great. Then others started. So then the commercial side, that was autonomy, started to fragment, and just to give you our own model, we got out of the hardware business back in 2015 because DJI was amazing. And you just couldn't compete, and that's fine because the hardware was now so ubiquitous and so good that we could assume it. Again, following the Android model, the beauty of Android is that you don't have to buy a Google phone. You can buy a Samsung phone or HTC or OnePlus or whatever. And so there was this commodification of the hardware side, and that's great. But the software continued to be our core. We're basically robotics people, and if the hardware commoditizes, you want to make not only innovate on the software, but also innovate openly on the software. So the software is both the data and the drone stuff. So what we did is we decided to make a company all about the data. So that's like the commercial use of that data, the analysis of the data, the management of the data. But the drone software, we were committed to open source and to making an open community. That's the Android model. So we stuck it into the Linux Foundation as drone code. And there are today two actual projects, both of which I started, both Drone Code and ArduPilot. One of them is commercially licensed, and the other one is sort of non-commercially licensed. And today, that is the evolution of the Android vision that we had 10 years ago, which is a industry consortium that opens up the stack, and it's basically the alternative to the closed source stack. We love DJI. We use DJI for most of our applications, but for some of them, people want to get deeper into the stack. They want to be able to, to control every element of it. In some cases, they want it to be open and transparent so they can verify and make sure it's secure. In other cases, they want to modify it and create new businesses around it. So this is essentially the migration, and this is the way we started, and this is we got to this stage, for the $500 of investment and all this kind of stuff, and now I think we're now hitting this phase where the drone itself is kind of a solved problem. You can go to Walmart and you can buy an amazing drone that kind of works. And I think as you're hearing across the board, we're all starting to focus on applications. Some of those applications have regulatory challenges, like PK was saying. Some of them have data analysis challenges. Some of them have to just understand the use cases, like the paper mill one is fantastic. I mean, when I hear that the scaffolding costs $80,000 or $250,000, that is gold, right? That is exactly what we in the technology industry need to hear, because we know a lot about robots and not a lot about paper mill scaffolding. And that matching of those two is what's going to take us to the next level. So what's interesting is that as we were doing this, and again, I'm an editor of a magazine. I'm doing this as a hobby. We're creating lots of websites, but this notion of openness, there were tons of other projects out there. And the difference between the successful projects and the unsuccessful projects over long term is not whether they had brilliant people or good code, it's whether they had lasting power. And basically, successful open source projects are the ones that continue to attract developers, grow, maintain, document, bring in members, just grow. And so all these ones, and many of you have heard of, they all died. And they all died because they just didn't, this is a multi-decade process. And you need to create an institution, a community that can last for multiple decades. So we're now on our second decade. DIY drones started in 2007. And I'm still having fun. It's still incredibly thrilling, but it's going to take about another 20 or 30 years of community building, or maybe even longer. The reason we succeeded is because we understood that as projects mature, they have to establish structure. They have to actually look more and more like a company, more and more like, I was going to say GE, but that may not be the best example anymore. And they have to have things like governance structures and licenses and roles and responsibilities and dev calls and pull requests and documentation and teams that do documentation. And it actually starts to look like a company. And so one of the advantages of going into the Linux Foundation is that we're able to essentially adopt many of the governance and project management skills that brought us Linux, and that's great. And the things that are super important, so governance is really important, because if you're a company and you want to use open source software, you might want to know that it's going to be there tomorrow. You might want to know that the maintainer is not going to shut it down tomorrow because he's in a bad mood, which, by the way, happens. You might want to know that it's funding, or maybe you want to fund it, and you want to know that funding goes into a place with a, with a board and some transparency. You might want to know what it's going to be doing next, and how you can influence that. You might want to know that it's actually professionally tested, and if you're the FAA, you really want to know that it's professionally tested, thus some kind of regulatory compliance. And you might want to know that the license is one that's not going to bite you in the ass. And you might want to know that it's maintained and that copyright is checked, and that if there's any violations of copyright or code injected, that someone's going to catch it. And this is all just normal stuff that takes us from the hobby days when I was crashing a drone into the Berkeley lab to today, where we have some of the biggest companies in the world contributing because they trust that we're running it like a professional operation. We learned a lot in this process, and we learned that open is a full spectrum. It goes all the way from hardcore open source to just app stores, and every one of these bits on the continuum has its place. So, for example, DJI is an open platform by some definition, which to say that they've got you can create an app and they've got an SDK, and if you go on certain ones, they even go further than that. It's a better SDK, and that's great. That's very much like the Apple model. If you want to get further into it, you want to actually see the source code up and down. But even there's different kinds of licenses. These so-called permissive licenses, like BSD and Apache, are fantastic for companies, because what that means is that you're absolutely free to use the code, you're free to modify the code, and you don't have to re-release it. In other words, you can use it, you can sell it, you can keep your modifications secret, and that's totally cool. It's great for companies, it's great for commercialization. Lawyers, and all companies have lawyers, they're only really comfortable on the so-called permissive side. However, if you go into the sort of the hardcore open source, some of it goes to the so-called copyleft side, which is GPL v3 being the most extreme. GPL v3, if what you're trying to do is optimize for developers, GPL v3 is fantastic because it's a stick that forces people to open source their code. So if you take GPL code and you modify it and you sell a product, you are required to open source that product. You're required to publish your source code. Now, again, very good for developers, very bad for companies. Essentially banned in Silicon Valley. Google, Amazon, et cetera, will not touch GPL v3 because they consider it viral. Both of them are great. I started this project and loved it. I eventually, when I became an entrepreneur and a company, and we started working with other companies, we had to abandon that and move to our second project, Drone Code, which is based on the PX4 stack. And it was a very, very tough decision. But this is something that, as you guys think about open source, both at the student level, et cetera, and it's becoming a big issue in China right now, people need to understand that there are consequences to choosing the wrong license, and there's consequences to code that has the wrong license. And I'm not saying one is better or one's worse. I'm just saying if you use GPL code, you are going to have to open source your stuff. And if you use GPL v3 code and you don't tell your lawyers, you're going to have to answer to them. And this involves patents, it involves patent portfolios. There are real consequences to that. So I didn't know this back in 2007, 2008, 2009, we were making the decisions, and it was an extremely painful process to realize that if I believed in commercialization of drones, and if I believed in building companies, and if I believed in bringing in the biggest technology companies in the world, like the ones I'll show you in a second, but including the Googles and the Amazons, et cetera, that we were going to have to abandon that stack and instead build our second stack on the permissive license. And we basically forked the project. I became sort of public enemy #1 in the GPL community, and it sucked because I love the people, I love the code, but licenses matter. So today they're all doing really well. This is the way we measure vitality, is the amount of contributions, and these are the top 5 drone community stacks. And as you can see, this is the one today. This is the one I started and used to run, and those are ones that kind of came out of the drone racing world. These ones are essentially built around autonomy. These ones are essentially built around manual flying. So this is really what we're looking at, and they're both extremely active, and they're both doing great. And they sort of slightly compete, but more to the point, they're bringing the smartest people in the world to solve many of the problems that you described, from payloads to machine learning to safety to compliance, et cetera. Drone Code's more built around commercial use. ArduPilot's more built around hobby use. And some sort of nonprofit stuff. It's just thrilling to see them both so successful. And meanwhile, the great thing about the hard choices we made about licenses and creating Drone Code and creating the governance structures, we now have some of the best companies in the world contributing this. Very much amongst them. And it's just great. There's a whole bunch that you can't even. I mean, we haven't even listed ARM. Oh, there's ARM right there. But when you look at NXP, one of the biggest chip companies in the world, now embracing it, they're running a hackathon this week. ARM also running a hackathon this week. NXP is doing a drone racing hackathon, but autonomous racing, no sticks. ARM is running an autonomous navigation contest this week as well. Chinese companies like Trimble. And everything you heard about Honeywell, I mean, it's just fantastic that a company with deep aerospace roots can see the virtues and advantages of creating an open stack. The FAA is participating in this as well. And I mentioned China earlier. It turned out that hundreds of Chinese companies were using the software, but they didn't tell us. And that's cool. They don't have to tell us. That's the whole point of a permissive license. But by not telling us and not participating, they also weren't benefiting from all the improvements of the software over the past few years. And now that DJI has become so prominent, and now these Chinese companies want to sell outside of China, they are decloaking as Drone Code users and Drone Code members, and they're starting to join. And that's fantastic. I love it. But what it means is that they now have to basically catch up. So they forked the code like 3 years ago. They made a bunch of modifications, And now, in exchange for participating, they're going to need to rebase on master, which is basically sync up with where we are today. And that is going to lead to a huge amount of development and innovation. To participate is going to mean that there's going to be a standard platform out there that many Chinese companies are going to embrace. And it means that hopefully we'll be able to educate Chinese engineers who are among the best in the world about the advantages of not just taking open source software, but also giving back. And this takes a long time. It takes generations to really explain this. But I think with this economic driver to embrace open innovation and sell transparency and accessibility, that we now have an economic incentive that will convince people. What's driving it, I'm almost done here, what's driving this different alternative is things you know about. Concerns about DJI and Chinese companies in general on security. You saw the crazy Business Week cover, which is probably wrong, but the one about sort of spy chips in boards. Huawei, Hikvision. Right now we're in the midst of a trade war with China. I think, by the way, this is deeply unfortunate. I am a Chinophile. My children were born there. I've lived there for almost 4 years. But that is the world we live in. We live in a world where security and international trade wars are a thing. And one of the virtues of an open stack is that it's transparent. You can see every line of code, and you can and it's there, and you know that that whatever's in your drone has been digitally signed off master. So you don't take anybody's word for it. You can actually see it, just like Linux. So I think transparency has become the new security, and that's one thing. The U.S. government and military is now starting to the commercial off-the-shelf technologies, low cost, all these things we heard about. It is now considered, it's like, the U.S. government can either buy an expensive drone for an aerospace company, or they can go to Walmart and get a Mavic. I don't know about you, but I mean, the Mavic's pretty awesome. And that's kind of what they want, but they want a transparent stack. So the Defense Innovation Unit is now mandating open software, and you're starting to see things like Linux, et cetera, increasingly get acceptance in the government. And then finally, the FAA, with the new reauthorization, has been mandated to accelerate the certification process and integration process, and have a mandate to embrace industry standards, which means not one single company, but in rather a consortium. Unfortunately, we're the only game in town there. So this is my final slide. There's just a bunch of other things this dream that we had 10 years ago, there's a bunch of other things that are finally making it real. The drones just are great right now. They don't crash anymore. They're really simple to use. It's basically a lot of the problems, the barriers to commercial use have gone away because we've just done all the hard work. I mean, the Skydio one is a perfect example. The world is going open. Selling open source used to be radical communism, fantasy, delirium stuff. But now it's like, of course, everyone understands that opens are the way to go. And the notion of horizontal layers, where you like the PC industry, where you have, some people make hardware and some people make software and some people make apps. I think everybody understands that horizontal markets are the best. The flip side of DJI's success is that it's demand for an alternative, but no single company can provide that alternative because DJI is amazing. So the only real alternative is going to have to be companies working together, consortium and open stacks that allow people to get things like visual odometry, sense in the void. Aerospace comes for free, with these stacks. DJI has something like 15,000 engineers. No single company is going to be able to compete with that at that price. So again, we have to work together. And I don't want to sound sort of like, like it's taking sides. There's a place for both of them. And it's really just some industries. To fly anything, I'll fly a Mavic because I love it. And the vast majority of our work in the commercial realm is using DJI. But for those companies who can't use DJI, it is fantastic to have an alternative that is increasingly as good. And then finally, we talked a lot about urban air mobility. But this, this rise is starting to introduce demand for different form factors, vertical takeoff and landing, hybrid, gas and electric designs, and all this stuff is a new sort of burst of innovation and experimentation, a Cambrian explosion of form factors. And there's an open platform that's more modifiable at the low-level control theory side. We've created a consortium. We created rather a joint venture with one of our members, Unique, and we're taking Chinese hardware and American software, and we are going to be releasing next week, 2 weeks, I guess, from now, a vehicle that's of commercial grade. This will be used for things like critical infrastructure, airports, ports, refineries, electric utilities, things like that, where security is needed. It'll also be, police and fire, other places that demand an alternative. So it's really an interesting time to be doing a joint venture with the Chinese companies, and we really worked hard to structure it so it can withstand the winds of politics, if you will. That's what it looks like. There's also a small one called the Mantis, which is like the Mavic form factor. And finally, I just said my last slide. This really is my last slide. And then we, again, for this open platform, we're starting to integrate with other open platforms like ESRI, Autodesk. Anybody that's got an API and an SDK is easy to work with, and it so happens that ESRI, the geospatial giant, has been working with us for a couple of years, and now we're going to be integrating all that geospatial data into this open stack. And if you are participating or using the form, you will get this too. Thank you very much.